Hey everyone, my name is Patrick Tran. I'm a data scientist from the Special Project Group at the University of New South Wales. Today we are diving into something pretty interesting, assessment analytics, with a special focus on item analysis. Now before we get into the nitty-gritty, let's quickly frame our discussion. Assessment analytics is a fancy term for digging into the test scores and seeing what they tell us about our assessments and the students taking them. First off, let's talk about keeping an eye on how students are doing. If you ever use any learning management system like Moodle, you know we can see scores for each quiz or assignments. It's like having a snapshot of where everyone stands. But sometimes just looking at those numbers isn't enough. What if we want to see the whole picture, like how the entire class did overall on a question? Moodle is great, but it doesn't offer a holistic view, especially to see trends and patterns. So a little trick is to pop that data into Excel. That way you can play around with it and really see what's going on. Now, moving on to the heart of our discussion, item analysis. This is where we turn our focus to the test itself. It is not just about individual scores. It's about examining the quality and effectiveness of each question within a test. Are the questions fair? Are they too easy or too difficult? To answer this, Moodle calculates two critical metrics for us. How many got the question right? That's the facility index. And how well the question separates the top scorers from the ones struggling. We call that discriminative efficiency. A question with a high facility index might be too easy, whereas high discriminative efficiency suggests it's good at differentiating between high and low performing students. So how do we calculate these metrics? Here's where it gets a bit technical, but bear with me. When you export your test data, you will see scores for every question. The first column is the total score of a student. For the facility index, it's straightforward. Calculated as the number of students who answered correctly divided by the total number of attempts. In practice, we are aiming for questions that are neither too easy nor too difficult. Ideally, a facility index around 0.5 is perfect, indicating a balanced difficulty level. Anything below 0.35 is too hard, and above 0.85 is too easy. Discriminative index, on the other hand, measures a question's ability to distinguish between those who understand the materials and those who don't. We calculate it by comparing the performance of the top and the bottom groups of students on each question. Now, this gives us a sense of whether a question can effectively separate high performers from low performers. This metric, however, has its limit. A question with a very high or very low facility index tends to have its discriminative power approaching zero. We can address this problem by utilizing a better metric, the discriminative efficiency. We first calculate the covariance between the question scores and the total test scores, excluding the question itself. We then sort the two columns, arranging data to estimate the potential maximum covariance between them. Now, this sorting allows us to estimate the maximum relationship a question could have with the overall test performance, giving us a clearer picture of its discriminative power. Speaking of making sure the test is doing its job, let's discuss reliability. This is all about consistency. If I took the test today and then again next week without studying more in between, I should get a pretty similar score. That's what we aim for, a test that gives us reliable, consistent insight into our students' learning. This is where the coefficient of internal consistency comes in, with crunchbatch alpha being the main indicator. A high alpha means our test is solid, giving consistent result over different groups and settings. In practice, our analysis allows us to identify, refine, or replace questions that don't perform well, adjust the test structure, and provide targeted feedback to students. This ensures our tests are not just fair and challenging, but effectively measures what we intend them to. This insight encourages us to reflect on the educational intent behind each question. Are we testing basic understanding, or are we trying to differentiate between mastery levels? And depending on our goals, the ideal facility index and discriminative efficiency can vary. For assessing basic understanding, a higher facility index is desirable, indicating a majority of students comprehend the materials. However, for differentiation, a balance with a lower facility index and a higher discriminative efficiency may be more effective, ensuring the questions challenge students in a way that underscores the depth of their understanding. Now, when dealing with assessment that spans across a range of topics, the ideal metrics for facility index and discriminative efficiency can vary depending on the subject focus. Yet, in all cases, we strive for strong internal consistency, even though achieving this may be difficult for some assessments. In rare situations where discriminative efficiency turns negative, we have an inverse relationship between answering the questions correctly and the overall test performance. This means that the students who usually struggle might get this question right, whereas high-performing students might not. This could signal a potential misstep in our test design, perhaps an error in the answer key, where the correct answer is marked wrong or vice versa. In summary, what we are doing with item analysis is making sure our assessments are not only challenging and fair, but also effectively gauging student understanding. It's about tweaking questions here and there, maybe rethinking a few, and aligning them with our educational goals. I hope it helps you see just how powerful a tool item analysis can be in enhancing the quality of our assessments and, by extension, our teaching. As we continue to unlock the potential of our assessments, remember to take these insights back to our classrooms and make every question count. Thank you.